Okay, this is the practice test for chapters 6 through 10, and it's on confidence intervals and hypothesis test. And problem 1A says a teacher claims that the average on a statistics test is 60. The students of this class believe that his claim is too high. Right here is the main thing that's giving you the alternate hypothesis. They believe the claim is too high, so in other words, they think the population mean mu is less than 60. So that would be your alternate hypothesis, making your null hypothesis mu is greater than or equal to 60. Okay, so this is a 1 mu test here, test for 1 mean. So they sample 15 people and got the following scores, test the claim and summarize the most significant alpha level. So what we're going to need to do is take our data right here and copy that over to, or retype it in to the 1 mu sheet and do a left tail test. So let's go to the Excel sheet, and now we would type our data in right here. We're on the 1 mu sheet. Type your data in right here. After you have your data typed in, which I already have typed in, click the copy values button. And when that gets done copying, remember we were going to do a left tail test. So we'll look here at the left tail test area, and we have to put in our claimed mean, and our claimed mean was 60, so make sure you type in the 60 right there, because there is no place that was copied, so you have to type that in. If we check this, our p-value is 0.3042, so we're not going to reject this at any alpha level. Even the 0.1 alpha level, we wouldn't be able to reject it. So the summary on this problem would be at any alpha level, I was unable to show that the average grade for the statistics class was significantly less than 60. So it may have been a little bit less, but it was not significantly less. The average for those 15 people was 57.8 with this standard deviation, and that's not enough less to make the inference up to the entire population. So that's problem number 1A, and problem 1B is get a 95% confidence interval for this data. So all we do here is on the same sheet, we just scroll down a little bit, and we put in our confidence level right here, 0.95. These values should already be copied over when we click the copy button. So our 95% confidence interval is right here. So I'm 95% sure that the average grade is between a 48.8 and a 66.8. Problem 2 says a statistics teacher claims that students significantly improved their grade from the first statistics test to the second statistics test. So he sampled 15 students and got their grades on the first statistics test, and sampled the same 15 people and got their grades on the second statistics test. Check the teacher's hypothesis with the following data and summarize at the most significant alpha level. So we basically have a pre-test, post-test going on. We're sampling the same people, so this is called a paired T-test, and it's a dependent sample. The null hypothesis is that mu d, that difference, which we get from taking the pre-test minus the post-test, equals 0. Mu d equals 0 is the null hypothesis. The alternate hypothesis, since we're expecting the post-test, like here, claims that they significantly improve their grade from the first test to the second test. So we're expecting their second test here to be higher than their first test. So if that's true, when I take first test minus second test, I'm going to get a negative value. So I'm at least expecting to get a negative value, which means that this is a left tail test. So I'm going to be doing a left tail test on a paired T hypothesis test. So we need to get the Excel sheet up here. Here we go. And now we want to go to the paired T-test, and on the paired T-test we are doing a left tail test, and make sure you have your data. This is our data for the first test and second test, and once you get these values in here, you have to click the copy values button, and that copies the values over. And again, we're doing a left tail test, and if we check this p-value out, we see that it's less than 0.01 even. So we could summarize this clear down to the 0.01 alpha level. At the 0.001 alpha level, we would get a do not reject, so the most significant alpha level would be 0.01. So that would be the results on that. We would reject the null hypothesis at the 0.01 alpha level, and the summary would be at the 0.01 alpha level I was able to show that the students significantly improved their test from the first test to the second test. Moving on, the third problem says the statistics teacher claims that the average grade on the third test last year was significantly greater than the average grade on the third test in statistics this year. Well, right there is your alternate hypothesis. The mu for last year is greater than the mu for this year, making your null mu last year less than or equal to mu this year. So this is going to be a right-tailed test. So we sampled 10 people from last year's class and 8 different people from this year's class. So this is an independent sample. This is an unpaired T-test because we're sampling different people in 2 different populations. And it says test the teacher's claim and summarize at the most significant alpha level. Well, this is an unpaired T-test, and this is a right-tailed, because this inequality sign here, this is a right-tailed test. So let's go to the unpaired T-test, and we have to make sure we get our data in for group 1 and our data in here for group 2, and then once we get that data in there, click both of these copy values button, and let's click the other one. Now, if I remember right, we were doing a left-tailed test, and on a left-tailed test, let's see here what we got. On the left-tailed test, I'm getting a p-value of 0.6055. Let me see if this was a left-tailed test again. No, it's a right-tailed test. Still, it's going to be a do not reject the null hypothesis because my p-value is 0.3945, and that's not less than any standard alpha level. Even an alpha level of 0.1, it would be do not reject the null hypothesis. So we would say at any alpha level, I was unable to show that the average grade for last year on the third test was significantly greater than the average score for this year on the third test. On problem 4, it says the statistics teacher claims that only 30% of statistics students have a grade of C. The class believes that this claim is too low. So in other words, if they think the claim is too low, they think that the percentage is greater than 30%. So that's your alternate hypothesis there, making your null hypothesis P is less than or equal to 30%. Samples, so he samples 20 statistics students, that's your N, and finds 10 of them have a grade of C or higher, summarize the most significant alpha level. So this is a hypothesis test for a single proportion, and it's a right-tailed test. So we go to the Excel sheet for a 1P test, and it was a right-tailed, right-tailed test, yes. And so we would put in here our claim proportion was 30%, our N was 20, our X was 10, and we get a p-value of 0.025, which is less than this alpha level. And that's the most significant we can make it. If we try 0.01, it's a do not reject. So 0.05 is the most significant alpha level on this problem. So let's summarize this. So we would say at the 0.05 alpha level, I was able to show that the percentage of students that got a grade of C or higher is significantly greater than 30%. So in other words, the class was right when they thought that the claim of 30% was too low. It is significantly greater than 30%. A 95% confidence interval in the previous problem, on problem 4b, getting a 95% confidence interval, we would just go to the same sheet, 1P, put in 0.95 here, your 20 here, your 10 here, and your confidence interval is right here, and we could say that I'm 95% sure that between 28% to about 72% of students get a grade of C or better. And let's go ahead to the next problem. On 5A, it says a statistics teacher claims that the percentage of students passing this semester is less than the percentage of students that passed last semester. So that's your alternate hypothesis here, that P this semester is less than P percentage of people that passed last semester, making your null hypothesis P this semester is greater than or equal to P last semester. So this is a difference of two percentages. We got our N1 is 20, our X1, our number of successes, was 10, our N2 is 20, and our number of successes is 14. So we want to do a left-tailed test for two percentages. So let's go to that, two percentages, and we want to do the left-tailed test. And here's our N1, X1, N2, and X2. And down here we can see our p-value is 0.09. Now we'll reject this at 0.1, but that is the most significant alpha level. We try 0.05, that's not less than 0.09. So the most significant alpha level on this problem is 0.1. So at the 0.1 alpha level, I was able to reject the null hypothesis. So the summary on this problem would be at the 0.1 alpha level, I was able to show that the percentage of students that passed this semester was significantly less than the percentage of students that passed last semester. So we were supposed to run at the 0.05. At the 0.05, we were unable to show that, since it was a do not reject the null hypothesis. At 0.1, it was a reject the null hypothesis. And how would you summarize it? In a paper, you would summarize it at the 0.1 alpha level where you were able to reject the null hypothesis. So we'll stop here on this video, and we'll pick it up on problem 6 on the next video.